Student page 123. All right, two more equations. We're going to need to solve these again by sketching the graph and algebraically. So let's start by sketching the graph. I'm going to go ahead and pick my favorites, 0, 1, and 2, and we'll see what we get. 2 times 0 is 0. That leaves y equal to 4. 2 times 1. 2 times 1 is 2, so 2 more would give us 4. And then 2 in here. 2 times 2 is 4. We don't need anything more. Y can be 0. Nice. We'll graph those in a minute. Next, we're going to switch and we're going to look at our 2x plus 3y. So I'm going to go ahead and put 0 in for x. When I put 0 in for x, we get 3y equals 9. And it's pretty easy to see that y is 3. Now, if I put in 1, I'm going to get 3y equals 7. I'm not very excited about that, but another trick I like to pull off is just put in a 0 for the y. Why not try the two x's? So if we let y equal 0, that's going to get rid of this guy, and we get 2x equals 9. And then we can see that x equals 9 over 2. Not as nice as some numbers, but it's certainly better than some other choices that we might have. Yeah, we'll keep that. Okay, we're going to go ahead and graph these. Now that these are graphed, we can see that we have a problem. This is not an easily identified point. It's not on one of our little hash marks, and so we know we have a fraction answer. So instead of trying to guess from the graph, it's easier to try to figure out what's going on from the equations. What I'm going to do is recopy the bottom one, which is 2x plus 3y equals 9. And then I'm going to switch signs for everything on the top, and you'll see why in a minute. But we make everything into its opposite, and that's going to give me this equation that looks like this. Negative 2x plus negative y equals negative 4. And then I'm going to add these up like it's just a great big addition problem. And what happens is something rather pleasant. That is a 0 pair. 3y minus y is 2y, and 9 minus 4 is 5. And what we come up with is that y is equal to 5 halves. So let's see, y is 5 halves. Well, that could be. 5 halves would be between the 2 and the 3, and this is the 2 here, and this is the 3 here, and that certainly does look like it's somewhere in the middle. All right, well, if y is 5 halves, we have to figure out the rest of this. So I'm going to go ahead and just take the original first equation, y plus 2x plus the 5 halves equals 4. I'd like this problem a lot better if that 4 were actually in halves. So I'm going to remove it, and I'm going to consider that 8 over 2 is the same as 4. So we're going to subtract 5 halves from both sides. 5 halves minus 5 halves equals 8 halves minus 5 halves. Excuse me, sorry, hold on, let me get that. Let's make this right for you. So that 2x equals 3 halves. And the only way we're going to get out of this is by multiplying by 1/2. 1/2 of 2x is 1x. 1/2 here, and x is going to equal 3/4. So we have our unpleasant but true, and it looks like this is before we even get to the number 1. We have our unpleasant but true answer of the coordinates being 3 over 4 and 5 over 2. Yay. Well, now that I've remembered there's an easy way to do a problem, let's go ahead and use 0 for x and 0 for y. If x is 0, then this is 0 and y becomes 5. If y is 0, then we get 3x equals 5, and that means x is going to equal 5/3. Okay, don't love it, but it's life, 5/3. 0, 5, 0, 5, 3, 4, 5, here's 5, 0, 5, And then 5/3. 5/3 is between 1, which is 3/3, and 2, which is 6/3. So it's somewhere right about here, and that's where we're going to put our point. All right, 3x plus y equals 8 is our next challenge. And so I'm going to go again with 0 and the 0. If x is 0, y is 8. That's good. We'll take that. And then again here, if y is 0, then we get 3x equals 8, and that means x equals 8/3. Well, that's another one that we're not real thrilled about, but it's life. All right, 0, 8. 0, 8 would be up here, 3 above. And 8/3, well, this was 3/3. This one is 6/3. So 3 would be at 9/3. And that makes 8/3 right up here next to the 9. And now we're ready to draw our lines. That's an interesting set of lines. They don't intersect. These look like they're relatively parallel. So let's go ahead and see if we can confirm that. I'm going to go ahead and change the signs of everything on the bottom. And then we're going to do some addition. So we're going to say 3x plus y equals 5. And negative 3x plus negative y equals negative 8. Oh my goodness. We have a 0 here. That's a 0. We have a 0 here. 0 plus 0 is 0. So when we add that side up, we get 0 equals negative 3. And that is confirmation. This is a false statement. And that tells us that these two lines cannot intersect. Now, suppose the system of equations from exercise 1C was instead a system of inequalities, one with a greater than and a less than. So I've gone ahead and put down all the significant points from the last one. You can see we have no intersection. Well, if we think about it, 3x plus y is less than or equal to 8. So we're going to test now with 0, 0 into 3x plus y is greater than or equal to 5. 3 times 0 plus 0 greater than or equal to 5. And that would say is 0 greater than or equal to 5? Well, I want to say 5, and that is false. So what we know is that this line is going to shade in this direction, off into the Netherlands, but off into here. So now the next thing we're going to do is we're going to check the second equation with 0, 0. 3 times 0 plus 0 less than or equal to 8. Is 0 less than or equal to 8? Yes, that one's true. So that means the purple is going to shade down this way. And now what's happened, and of course they really should be shading longer, but you know, time. Okay, so it says what happens now? Well, what happens is we get this area in between the two graphs. All of this area becomes feasibly a possible solution. Now, shading this in is not a lot of fun. But there you go, you get the idea. That little bit of strip of area could be an answer.